Hey everybody, in this video we're going to walk through some of the wavelength, frequency, and energy calculations that you can do for electromagnetic radiation. In this example, let's say we've got 184 kilojoules, that is the energy of 1 mole of photons. And from that we've got to figure out, what about just one single photon? What's the frequency of this wave? And the wavelength of this wave. Let's get started. So the first thing would be to take this 184 kilojoules, which I'm going to actually write a different way, kilojoules per mole, because that's what it is, right? It says in this label here, this is the energy of 1 mole of photons. So you could write that, kilojoules per mole. And we're going to swap this over to instead be in joules, and instead of for a mole of photons, for just one single photon. For this, I like to use dimensional analysis and just think about canceling off these units, right? So we got to get rid of kilojoules, cancel it off top to bottom, and change that instead into joules. Of course, 1 kilojoule is 1,000 joules, and we can actually keep going and cancel off moles and change that into individual photons, because we know 1 mole of anything is 6.02 times 10 to the 23rd of that thing. And this gives me 3.056 times 10 to the negative 19. 3.056 times 10 to the negative 19th joules. We can write that up here to officially keep track of everything. Maybe we'll round it off to 3 sig figs. 3.06 times 10 to the negative 19th joules. And I didn't give myself a lot of room here, so let's move those calculations down a bit. Okay, cool. So now we know the energy that one single photon will have. It's a very small number, but it should be small because it's just one single teeny tiny little photon. From this, we can calculate the next piece of information we need, which is the frequency of this wave in a unit that is 1/seconds, sometimes also called hertz. To do that, we need an equation, and that is the energy of a photon is equal to 2 things multiplied together. One is this lowercase h, which is called Planck's constant. It's a number that you can look up, or you're probably given typically on like a reference sheet for whatever class you might be in. And if you multiply that constant times the frequency, you'll get the energy of 1 photon. Now in this case, the energy of the photon is what we know. 3.06 times 10 to the negative 19th joules is what gets plugged in. Planck's constant, if you look it up, is 6.626 times 10 to the negative 34 joule seconds. And that is multiplied by the thing I want, the frequency. So we're going to leave that as the variable to solve for. That means I'm going to divide both sides by Planck's constant to algebraically cancel it out. 6.626 times 10 to the negative 34 divided on both sides. And that's going to leave me with the frequency equals 4.61 times 10 to the 14th, and that's going to again be in 1/seconds. After those joules cancels out, I'll have seconds in the denominator, and that is my official answer for frequency. Let's write it down up top. 4.61 times 10 to the 14th seconds to the negative 1. Next up, we can find the wavelength, because there's another relationship where if you take the wavelength of any of these waves and multiply it by that frequency, you'll always get the same value. And that value is the speed of light, symbolized with a lowercase c. The speed of light is also a constant number that you would be given, or you can look up, 2.99 times 10 to the 8th meters per second. The wavelength I don't know, but the frequency I do know, because we just calculated 4.61 times 10 to the 14th. And if you plug that in, you can solve for that wavelength value by, of course, dividing both sides by 4.61 times 10 to the 14th. This will leave me with my answer, 6.49 times 10 to the negative 7. As far as units go, look at the units on speed of light. It's meters per second. The second or seconds cancels off when we divide, but the meters is left. So the wavelength you'll get anytime you use this equation is going to be in meters. 6.49 times 10 to the minus 7 meters. So at this point, we're pretty much done with all the things we can calculate. We know the energy of a single photon, the frequency, the wavelength. There is one last thing here, which is solve for the wavelength again, but this time in units that might make a little more sense for the type of number this is, right? That's an extremely tiny number. That's because the wavelength has units meters. So a lot of the times for small wavelengths like this, you might be given or be asked for different units like nanometers. So we're going to make one last switch to convert this same number just into a different unit. Of course, for this we'll just use dimensional analysis. 6.49 times 10 to the negative 7th meters. If I multiply with meters on the bottom, nanometers on top, of course 1 meter is 10 to the 9th nanometers. You can look that up in any metric conversion chart. And this gives me a final answer of 649, around 650 nanometers. That also wraps it up for this video. Thanks a lot for watching.